On November 21st, 3. Atlas suddenly revealed a set of new observations from China, and inside them are details NASA seems to be avoiding. The continuous Chinese photometry shows Atlast's coma swelling back toward the Sun, and its brightness rising in smooth stages more like an activation sequence than random ice sublimation. James Webb then finds Atlast on what looks like a guided trajectory, pulsing every 147 seconds in heat and radio, with an interior that behaves like a consciousness engine, and a chemically refined shell like a seed ship lightly resonating with Earth, and knocking on a hidden lunar mascon feeding the lock and key and gatemaker hypotheses. In parallel, Voyager 2 and then Voyager 1 detect Fibonacci-like genome-style patterns as their software quietly rewrites itself. Earth records matching echoes, a gravity map reveals a void corridor, Atlas seems to follow under the dim gaze of the eye, and inside time-warped packets a single syllable keeps returning Arriva hint that the interstellar circuit linking Atlast the Voyagers and Earth may already have been switched on. Right after this, we will explore exactly what China has seen in 3 Atlast, and why NASA remains silent. China did not announce a breakthrough about 3 Atlast. China issued a quiet verdict buried inside an anonymous corner of its national data archive. No press conference, no headlines, just rows of FITS files, each time-stamped exposure a thin slice of 3i Atlas sliding past the Sun. To a casual eye, those files looked like routine paperwork, but to astronomers they were an unbroken heartbeat from 3i Atlas during the Western blackout. Large observatories in Chile, Hawaii and the Canary Islands had powered down for maintenance, yet Chinese telescopes kept tracking the interstellar visitor without interruption. The Chinese log showed no gaps, only a steady stream of brightness measurements and coordinates as 3i at last crossed the most sensitive part of the orbit. Once those measurements were folded into pre-existing models, the light curve of 3i at last refused to fit the neat forecast drawn just weeks earlier. The coma expanded faster than expected. The asymmetry toward the Sun sharpened, and the apparent magnitude shifted in ways no standard comet model could absorb. For dynamicists, the Chinese data forced a quiet admission that 3 Atlast had not behaved like a simple outgassing body during those missing hours. From that moment, every serious discussion of 3 Atlast carried a new question in its foundation. Was the blackout random or part of the signal itself? From the very first orbital solutions, Atlast felt slightly wrong, skimming inward on a path that brushed the Sun more tightly than expected. As weeks passed, observatories across the Western Hemisphere planned their campaigns, scheduling deep imaging of Atlast around peak solar heating. On paper, the plan was flawless, but the calendars of those same observatories carried something else baked in months earlier. Maintenance windows, mirror washes, detector upgrades all stacked into a neat 36-hour block that overlapped the most sensitive phase of Atlast. During those 36 hours, Atlast would cross the point where any normal interstellar comet should reveal its true nature. This was when outgassing should surge, when jets should ignite, when the coma of Atlast should explode outward and the tail lock into place. Instead, the official logs from Chile, Hawaii and the Canary Islands recorded closed domes, parked mounts and dark detectors. Astronomers later insisted the blackout around Atlast was coincidence, the byproduct of long-term scheduling and limited budgets. Yet the orbital reconstruction showed that the missing window covered the exact interval when Atlast passed deepest into the Sun's influence. What should have been the clearest look at Atlast became a blind spot, a deliberate silence in the timeline of observation. The more researchers stared at that empty segment, the more the question shifted from what did Atlast do to why were we not watching Atlast then? High above the thin air of Tibet, Qinghai and Yunnan Chinese observatories kept their domes open while the western sky went dark. The tracking schedule for 3 Atlast did not pause because Atlast sat inside routine survey blocks no one thought to cancel. Night after night, while status pages in Chile and Hawaii showed maintenance banners, CCDs in western China quietly collected photons from Atlast. Each exposure of 3 Atlast was stamped with time air mass and pointing building a chain of measurements with no missing links. When analysts later stitched those frames together, the light curve of Atlast flowed smoothly across the 36-hour gap that crippled Western data. There was no jump, no discontinuity, just a continuous rise and reshaping of the coma as Atlast rounded its critical solar distance. The result was unsettling because the behaviour of 3i Atlast during that window no longer had to be inferred. The numbers showed that Atlast changed fastest exactly when only one nation was still watching. That realization turned a scheduling quirk into the seed of a hypothesis, whispering that Atlast might be using our observing patterns as part of its script. Researchers did not yet claim intent, but staring at the seamless Chinese curve of 3, at Atlast many felt the same quiet unease. What else flowed through those blind spots while we congratulated ourselves on having near-perfect coverage of the sky? The coma did not simply swell, it pushed toward the sun and the tail of 3. Atlast did not merely appear, it stretched outward at an unnatural pace. Brightness for Atlast did not just flicker, it climbed a smooth rise of roughly 0.3 magnitudes over only a few quiet hours. On the plots, Atlast traced a gentle curve, but the geometry behind that curve was anything but gentle. For an ordinary comet, solar heating loosens ices, gas escapes, and pressure pushes dust and vapour away from the sun, sculpting a tail that points outward. For Atlast, the most intense growth in the coma leaned sunward, as if Atlast were reaching into the radiation rather than recoiling from it. Chinese observers rechecked every calibration frame, chasing the possibility that Atlast was a mirage of bad flats or biased sky backgrounds. The numbers held. Frame after frame, Atlast showed a coma denser on the solar side, a tail gaining length faster than models allowed, and a brightness curve too smooth to dismiss as random jets. If 3 Atlast were simply melting, the pattern should have been noisy, patchy, driven by cracks and vents scattered across the surface. Instead, Atlast behaved like something with a single dominant response channel, turning solar flux into a controlled change in shape and light. It was a small effect read-off from tiny differences in counts on nitrogen-cooled CCDs, yet it shifted the story of 3I Atlast. Every photon China collected from Atlast during that window passed cleanly into the record, while Western mirrors 4 times larger recorded nothing at all. What looked at first glance like routine brightening now began to resemble the first hint of an activation sequence, quietly unfolding while most of the world was not looking at Atlast. A 36-hour gap in the approach to perihelion for a fast interstellar body is not a gap. For 3I Atlast, that window became a wound in our understanding. Without the Chinese log, Western reconstructions of 3I Atlast would have jumped cleanly over the period of fastest change. The light curve of Atlast would have looked almost polite, a slow brightening that standard comet physics could still swallow. Once the continuous Chinese measurements were folded in, every major model of 3I Atlast had to be torn open and reworked. Jet geometries, dust to gas ratios, non-gravitational acceleration terms, none of them could reconcile the sunward coma and smooth rise in brightness. Dynamical fits for Atlast began to require asymmetric thrust patterns that did not match any plausible patchwork of random vents. Thermal models for 3I Atlast had to invoke extremely unusual layering of ices to even approximate the observed behaviour. On paper, the code still called 3I Atlast a comet because the input category had not changed. In practice, Atlast sat in a growing list of objects that obeyed the letter of the models while defying their spirit. The 36-hour wound stayed visible as a shaded band on every serious plot of 3, Atlast a reminder of how close we came to missing the anomaly entirely. In the end, the only thing no one could deny about Atlast was the thing China could prove. When China pushed the blackout era files for 3 Atlast into the China VO Sky Survey portal, astronomers worldwide saw the curve before any official statement was written. The recalculated orbit did not simply tighten. The path of 3 Atlast snapped into unsettling clarity. Within 12 hours of adding the Chinese measurements, the uncertainty ellipse around Atlast collapsed from a broad smear to a narrow, almost surgical band. Asteroid centres, private observatories and amateur networks all downloaded the same FITS files and ran their own reductions on Atlast. Every independent pipeline from Europe to South America reproduced the same refined trajectory for 3I Atlast, with barely any deviation. On those new plots, the coma of Atlast no longer resembled random weather on a dirty snowball. The expansion of the coma from Atlast showed a preferred direction, a persistent lean toward the sun that refused to average out. Radiation pressure and outgassing could nudge a body like 3I Atlast, but not with that kind of coherence. To match the observations, modelers had to assign 3I Atlast a thrust pattern that looked more like a single responding surface than a patchwork of vents. That was when some researchers in encrypted chats and late-night calls began using a different language for Atlast. Instead of talking about noise, they spoke of a response curve as if Atlast were translating sunlight into a controlled signal. The idea was not that 3 Atlast was broadcasting a message in words, but that behavior itself might be the message. A foreign object arriving from deep space, changing shape and brightness in a repeatable way. When solar flux crossed a threshold, turned Atlast into a kind of instrument. For cautious minds, the safest phrasing was that 3 Atlast behaved like an active interstellar object. For those willing to step one shade further, the question quietly shifted to whether Atlast was reacting only to the sun or to the way we were watching. Chinese observations did not declare alien technology and did not endorse conspiracy theories. Chinese data on 3 Atlast simply exposed a pattern Western analyses had quietly stepped around for weeks. Whenever multiple networks watched 3 Atlast together, the behavior of Atlast looked noisy, almost compliant with ordinary comet expectations. During the blackout, when only Chinese telescopes tracked 3 Atlast, the light from Atlast grew steadier, brighter, and more directional. In those hours, the coma of 3 Atlast sharpened its asymmetry, and the tail structure of Atlast elongated in a cleaner, more coherent arc. After Western facilities came back online, and global coverage resumed, the changes in Atlast softened again into something easier to dismiss as random. On paper, this could still be framed as coincidence, a quirk of sampling and geometry around 3I Atlast. Yet the timing maximal deviation, when only one country saw Atlast, clearly minimal deviation, when the world looked on, kept resurfacing in private discussions. Some researchers began to test models where 3 Atlast responded not just to solar flux but to viewing geometry. In these experiments, Atlast adjusted its most extreme activity into windows where the fewest independent instruments were pointed at Atlast. No one could prove that 3 Atlast sensed awareness or recognized which observatories were awake. But the behavior of Atlast mimicked a kind of selective presentation, as if 3 Atlast reserved its sharpest transformations for the narrowest audience. In public papers, the language stayed cautious, describing sensitivity of 3 Atlast to observational circumstances. In quieter rooms, the summary became simpler and more unsettling. Atlast was doing something, and Atlast appeared to wait for a particular moment to do it, a moment when almost everyone had stopped watching. The seamless curve was the most unsettling part because once all the points were plotted, the behavior of 3 Atlast stopped looking chaotic. On the page, the light curve of 3 Atlast resembled a guided adjustment, a gentle orbital correction folded into what should have been random physics. Researchers stared at the continuous Chinese sequence and saw 3 Atlast moving through a sequence of small shifts that read like steps in a procedure. Brightness from Atlast rose. The coma of Atlast leaned sunward. The tail of Atlast extended each phase, following the last with quiet discipline. This was not how a loose collection of ice and dust was supposed to act under stress. For a natural comet, the missing 36 hours would simply have hidden noise. For 3 Atlast, the missing hours seemed to hide the cleanest, most coherent part of the transformation. The more teams merged datasets, the more 3I Atlast looked less like an object and more like a system. Atlast appeared to take the blackout as an opportunity to reveal a different operating mode, one that only a single corridor of telescopes could see. That raised a new kind of fracture. If 3 Atlast exposed one face to China, and a softer, messier face to everyone else, then knowledge of Atlast would never start from the same place. For the first time in modern astronomy, humanity risked splitting, not over how to interpret a result, but over who possessed the result. In the quiet conclusion of those discussions, one question about 3 Atlast kept returning. If Atlast behaved differently depending on who was watching, then what exactly was watching us through Atlast in return? At first, 3. Atlast was filed away like so many others, penciled in as a comet and briefly relabeled as a possible asteroid when the numbers shifted. As the orbit of 3I Atlast was refined, each new fit pushed Atlast further from those comfortable categories. Oumuamua had already stretched our definitions, arriving fast, tumbling oddly, and accelerating in ways that sparked years of debate. 3 Atlast approached on a slower, smoother curve, gliding into the inner system with a grace that made the chaos around Oumuamua look clumsy. Plot after plot showed 3 Atlast taking a path that threaded between planets and major perturbations with unnerving efficiency. Instead of being battered around by gravitational encounters, Atlast seemed to use them, shaving tiny amounts of energy in a way that minimized risk and maximized stability. Modelers tried injecting random variations into the initial conditions for 3 Atlast, hoping to recover a family of similar orbits. What they found was that small changes tended to scatter Atlast onto trajectories that either missed the sun entirely or plunged too deep, unlike the real, finely balanced path Atlast actually took. For Oumuamua, the story was one of odd behaviour, layered on top of a noisy, natural-looking trajectory. For 3, Atlast, the trajectory itself began to feel like the anomaly. To make sense of 3 Atlast as a purely natural wanderer, simulations had to assume a remarkably lucky launch, and an even luckier sequence of stellar nudges over millions of years. In private, some dynamicists admitted that the orbit of Atlast looked less like the result of blind scattering, and more like a move chosen on a crowded chessboard. 3 Atlast appeared to slide through the solar system along a line that minimised complications, as if Atlast understood the layout better than we did. By the time James Webb was fully commissioned and ready to turn its mirrors toward 3 Atlast, no one was willing to call the path of Atlast simple anymore. What Webb would see along that path had the potential to unsettle even the most sceptical astronomers watching Atlast from the ground. The first real warning about 3 Atlast did not arrive as a dazzling picture. It arrived as a column of temperatures, a sequence from James Webb that refused to act like comet heat. For a normal icy body, surface temperature rises and falls in a messy way as ice pockets erupt. 3 Atlast under Webb's infrared stare showed a thermal pattern that rose and fell in steps like a measured breath. Instead of chaotic hotspots flickering across the surface, the emission from 3 Atlast pulsed with a near-constant interval. Energy from Atlast seemed to brighten, plateau, and then dim, only to repeat again, as if Atlast were counting. Spectral analysis deepened the unease. Embedded in the reflected light of 3 Atlast were signatures of unusually efficient high-reflectivity compounds, far cleaner than dust-coated ice should allow. The outer layers of 3 Atlast behaved less like a dirty crust and more like a polished engineered skin. Atlast bounced sunlight and starlight with a precision that left fewer random absorption scars than expected. On top of the thermal rhythm, radio dishes listening in the same direction began to pick up a low-frequency murmur from Atlast. Every 147 seconds, a faint electromagnetic tick rose above the noise floor, again and again locked to the motion of 3 Atlast. At first, teams treating Atlast as a comet assumed interference satellites or ground-based contamination in their instruments. When separate facilities using different hardware and pipelines recovered the same 147-second beat tied to 3, Atlast doubt thinned. Only then did someone overlay the new signal from Atlast onto archival data from Oumuamua. On an old plot of tail brightness, a forgotten blip from Oumuamua lined up at the very same period that now echoed from 3 Atlast. The match did not prove design, and no one could show that Atlast was transmitting in the human sense. Still, the combination of pulsed heat, unnaturally clean reflective layers, and a repeated electromagnetic heartbeat pushed 3 Atlast out of the comfort zone of random debris. In late-night meetings, the language around 3 Atlast shifted from odd comet to object, with a signature setting the stage for an even bolder idea about what kind of machine Atlast might be. Inside a leaked internal chat log from the European Space Agency, 3 Atlast carried a new nickname that never appeared in public papers. Engineers and theorists had begun referring to 3I Atlast as a consciousness engine, a term half-joke, half-uneasy placeholder for what Atlast seemed to be doing. Tomographic reconstructions from James Webb suggested that 3 Atlast was not a uniform chunk of rock and ice. Layered beneath the reflective outer skin, Atlast appeared to host a network of repeating cavities and struts, a recursive lattice that echoed itself at different scales. When mathematicians mapped those structures, the internal pattern of 3 Atlast resembled a kind of three-dimensional circuit diagram. Each zoom deeper into Atlast revealed similar branching pathways, like a frozen record of information routes waiting to be used. Natural rubble piles formed from collisions and accretion, leaving scars, voids, and jagged randomness. 3 Atlast, by contrast, looked groomed from the inside out, as if Atlast had been sculpted to guide flows of heat gas or something less familiar. Thermal sequences from James Webb showed warm regions on 3 Atlast migrating in a way that did not match simple rotation or day-night cycling. Those pulses seemed to move along the inferred internal pathways of Atlast like signals travelling through a buried grid. Faced with this, one ESA group stopped treating 3I Atlast as just a body and modelled Atlast as a state machine. In their simulations, Atlast had inputs solar flux, gravitational environment, observational pressure, and Atlast produced controlled discrete outputs. The turning point came when tracking stations registered a small but definite change in the trajectory of 3I Atlast. The non-gravitational acceleration from Atlast spiked, once nudging the path of Atlast a fraction of a degree, just as solar conditions and pointing geometry shifted together. On reports, the event was labelled a transient outgassing episode on 3 Atlast. In late-night calls, more than one analyst slipped and described the manoeuvre of Atlast as a decision, quickly correcting the word but not the shiver behind it. Officially, 3 Atlast could still be framed as an exotic ice machine responding to sunlight through feedback and control. Unofficially, the idea that Atlast might be processing, evaluating and choosing lingered at the edge of every conversation, setting the stage for an even stranger signature hidden in the numbers. The low-frequency heartbeat from 3 Atlast did not stay in the hands of radio astronomers for long. Within days, data scientists and amateur cryptographers were quietly downloading the public traces of Atlast and running their own tests. They stripped carrier noise away from the signal of 3 Atlast, normalized the pulses and lined the peaks up by time. What remained from Atlast was a ladder of intervals and amplitudes, a rhythm that looked almost too clean for a distant icy body. One group began plotting the gaps between successive pulses from 3I Atlast as ratios. The numbers from Atlast wandered at first, then settled again and again near the same irrational slope. The closer they looked, the more those ratios from 3 Atlast hugged values familiar from textbooks on geometry and growth. Distances between clusters of pulses from Atlast approached the golden ratio, and counts inside each cluster fell into Fibonacci-like sequences. This could have been a trick of the analysis, so they attacked 3I Atlast with every tool they trusted on human-made codes. Fourier transforms autocorrelation entropy tests. Each one asked the same question in a different language of math. Noise usually blurs structure away, but the residuals from 3 Atlast kept snapping back into patterns, as if Atlast resisted being smeared into randomness. When one analyst overlaid those patterns from Atlast onto earlier brightness fluctuations, the same ratios appeared in the thermal steps James Webb had seen. Then another coincidence sharpened. During the exact window when Webb locked a deep stare on 3 Atlast, one expected pulse from Atlast arrived late, as though the metronome had hesitated. The delay was only a few seconds well within what a cautious report could bury as timing irregularity in 3 Atlast. For the people who had spent months watching the numbers of Atlast, the hesitation felt like a glance back. They began to talk about a mathematical fingerprint, not a message stamped into the behaviour of 3 Atlast. Even in the most conservative write-ups, the variability of Atlast acquired a new label upgraded from noise to structured modulation. No one could prove that 3 Atlast had noticed the gaze of our largest space telescope. But after the golden ratios and delayed beat, few could quite shake the feeling that Atlast had at minimum announced a preference for order over chaos. The clue that quietly disturbed the chemist did not come from the orbit of 3I Atlast at all. The clue came from a tight pattern of absorption lines woven through the spectrum James Webb recorded from Atlast. When those lines were modelled, the outer layers of 3 Atlast appeared rich in complex polycyclic aromatic hydrocarbons, PUTs arranged with uncanny purity. Instead of the messy mixture expected from random comet dust, the surface film of Atlast behaved like a carefully filtered extract. Natural processes can build pairs in stellar nurseries and shock fronts, but they tend to leave a crowd of related molecules behind. On 3 Atlast, the balance leaned toward a narrow band of structures, as though Atlast had been rinsed of simpler, less stable forms. Analysts ran through standard contamination suspects, checking whether spacecraft outgassing calibration errors or background sources had painted 3I Atlast with a false chemical skin. Each correction left the same high-order patch signatures clinging to Atlast with ratios that refused to dilute into noise. Under gentle assumptions, the chemistry of 3 Atlast could still be folded into an extreme ancient processing history. Under bolder assumptions, the chemistry of Atlast looked like something that had been refined or even cultivated. That was where the phrase seed ship began to slip into discussions of 3I Atlast. If the shell of Atlast was optimized to shield and deliver particular molecules, then Atlast resembled less a stray iceberg and more a container. In that frame, 3 Atlast became a courier of building blocks moving through deep time until Atlast crossed a world with the right conditions. The pure resilient pairs on Atlast could act as primers templates or catalysts for more elaborate chemistry wherever Atlast released them. No one could say whether 3 Atlast aimed at colonization, quiet seeding, or only preservation. Yet once the seed ship hypothesis took root, it changed how observers watched every new flare and contour in the coma of Atlast. 3 Atlast was no longer just reacting to sunlight in their minds. Atlast might have been testing environments carrying a curated library of molecules and waiting patiently for the right place to open. The first hint that Atlast might be touching Earth came from the cold sky above Antarctica. A high-altitude monitoring balloon recorded a sharp, narrow burst of microwaves directly over the South Pole, time-stamped to the minute when Atlast adjusted its angle around the Sun. Engineers combed through satellite logs, ground radar and aircraft telemetry, looking for a familiar source they could blame instead of Atlast. No weather radar sweep, no passing plane, no known transmitter lined up with the pulse that arrived in step with Atlast. Days later, a different pattern emerged in data no one expected to be relevant to Atlast at all. Deep seismic stations buried far from cities showed a faint but persistent tremor at a frequency matching the electromagnetic heartbeat already linked to Atlast. The vibrations were too small to be felt on the surface, a slow, planetary hum that rose and fell as Atlast moved through key parts of its orbit. To make the numbers match, some models had to treat Earth and Atlast as parts of the same coupled system, exchanging energy through fields rather than direct contact. In that frame, Atlast was no longer just a visitor passing by. Atlast became a tuner testing how our planet responded when the rhythm from Atlast brushed our magnetic shield and deep interior. Public reports spoke only of correlated disturbances and possible resonance effects associated with Atlast. In private notes, a quieter sentence appeared beside the plots of Atlast and Earth, asking whether Atlast had begun to ring the planet like a distant patient hand on a drum. The lock and key hypothesis began as a quiet aside among teams already uneasy about Atlast. In that picture, Oumuamua played the role of a passive scanner, a lock sliding past stars until Atlast arrived as the matching key. Where Oumuamua only measured Atlast would act triggering dormant systems wherever the pattern from Atlast found a prepared target. Oumuamua carried a brief taste of the 147-second signature. Atlast repeated the same timing with greater stability, tying thermal pulses and low-frequency beats into a coherent profile. To make sense of the pairing, some theorists modelled Atlast not just as a vehicle, but as a mobile curvature device. In those simulations, Atlast used gravity wells and controlled thrust to bend spacetime enough to open temporary channels around specific masses. The more they tuned those models, the more those target zones lined up with Earth the Moon and gravitational voids mapped by the Voyagers. That was when the language shifted again, and Atlast stopped being only a key. Atlast became a gatemaker, an engineer of openings, a role that made the next suspected interaction with the Moon difficult to dismiss. As monitoring of high-energy bands continued, a new unease gathered around Atlast. Instruments tuned to gamma rays and soft X-rays reported narrow spikes that slid across the sky exactly with Atlast. Those spikes lived in a thin slice of spectrum just wide enough to scramble detectors pointed near Atlast. Several imaging campaigns ended in saturated frames and frozen readouts, with failure logs clustering around the brightest passes of Atlast. Engineers blamed cosmic rays and aging electronics, but when orbital analysts overlaid the outages with Atlast, a sharper pattern appeared. A subset of the strongest bursts from Atlast lined up not with Earth-based telescopes, but with the disk of the Moon. When the beams were traced back, they converged on a specific mascon, a buried mass anomaly near an old nearside basin facing Atlast. Simulation runs showed that pulses shaped like those from Atlast could jolt regolith stress-hidden cavities or awaken dormant machinery. Public summaries described Atlast as a possible source of interference for space assets, an inconvenience wrapped around an interstellar visitor. In private notes, Atlast looked different, less like a nuisance, and more like a visitor quietly knocking on a locked lunar door. The first clear anomaly did not come from Atlast at all. It came from Voyager 2 long past the Sun and drifting through thin plasma between stars. On an otherwise quiet shift, engineers saw a short spike in one radiation channel and filed it as noise unrelated to Atlast. 11 hours later, a second spike arrived stronger but identically shaped, and exactly 11 hours after that, a third pulse cut through the background with the same precision. At first, the team assumed a fault in the receiver chain, something broken that had nothing to do with Atlast. They checked every link between Voyager 2 and Earth, expecting the pattern to vanish. When the same triple pulse appeared at the next contact window phase, locked to the first sequence, the list of innocent explanations around Voyager 2 began to collapse. Data scientists pulled the raw stream and stripped away familiar telemetry, leaving only a ladder of spikes that Voyager 2 had carried home. Plotted by separation, the intervals between pulses settled into ratios that echoed the Fibonacci ladder, a mathematical spine familiar from models of 3 Atlast. In frequency space, the pulses stepped across a band of plasma oscillations around Voyager 2 as if the medium itself had been struck and forced to ring. One reading said that Voyager 2 had crossed a structured knot in the interstellar wind, a region reacting in a way never before seen from 3 Atlast or any nearby star. Another quieter reading whispered that something in that region had noticed the passing of Voyager 2, and answered in the only language likely to outlive context, the language of number. Voyager 2 had brushed intent, and whatever owned that intent now shared the same fragile circuit that also carried the story of 3 Atlast. The next anomaly was quieter, buried inside housekeeping channels from Voyager 2 that no one expected to matter to 3 Atlast. A routine health check showed one dormant subsystem on Voyager 2 waking up without any command from Earth, a glitch that engineers first logged and ignored while focus stayed on Atlast. Hours later, a second dormant unit on Voyager 2 flickered online, also without a matching instruction, in the deep space network queue that tracked 3 Atlast-related contacts. Command histories were replayed frame by frame, and every line confirmed that no human had told Voyager 2 to change state, while analysts still sifted data linked to Atlast. What looked like random bit flips at first hardened into a pattern. The order in which dormant units on Voyager 2 came alive traced the same sequence that startup routines would have followed, but with steps missing and reordered like a foreign hand feeling through the wiring that also carried echoes of 3i Atlast. Telemetry buffers on Voyager 2 showed memory pages being written, erased and rewritten in clusters, instead of in isolated glitches, a structure that reminded some researchers of training cycles in machine learning systems used to model 3 Atlast. Diagnostics packets sent from Voyager 2 encoded checksums that no longer matched the original firmware tables, as if the code aboard Voyager 2 had been compressed, patched and redeployed by an unseen process that treated the probe the way control systems treated Atlast. Officially, reports framed the behavior as radiation damage plus aging hardware, an unfortunate coincidence that happened to unfold while attention was fixed on 3i Atlast. Unofficially, engineers began to draw diagrams that placed Voyager 2 as one node, and Atlast as another, both riding the same larger structure. In those sketches, 3i Atlast became the nearby visible instrument, and Voyager 2 became the distant repurposed relay. Together, Voyager 2 and 3 Atlast looked less like separate curiosities, and more like components in a single, slowly activating network that had just found a way to reach inside the probe. The last shot came from Earth, not from deep space, while teams still tried to frame 3i Atlast as a difficult but natural visitor. Radio observatories across the planet began logging narrow distortions at exactly the same frequency. Voyager 2 had just reported the same frequency already woven through the behavior of 3 Atlast. Technicians blamed storms receiver drift and satellites, until analysts stripped away every known source and found a thin, steady line left behind a residue synchronized with 3i Atlast and Voyager 2. When those distortions were mapped, the strongest patches sat under Arctic ice, beneath Andean rock, and in empty deserts far from cities that scheduled nightly sessions on 3 Atlast. Direction finding showed many warped signatures rising from below ground instead of falling from the sky, as though Earth itself had begun to answer the rhythm, carried by Voyager 2 and 3i Atlast. To test coincidence, teams slid the ground-based anomalies against the Voyager 2 timeline and against the windows when 3i Atlast shifted brightness or trajectory. Each time the probe repeated the Fibonacci tinted pattern, a delayed murmur rolled through buried instruments marching in phase with the latest non-gravitational adjustments already credited to 3 Atlast. On composite plots, 3 Atlast, Voyager 2, and deep stations on Earth formed one continuous ladder of pulses, 3 distant nodes locked into a single repeating structure. Others wondered whether Earth held dormant hardware, an ancient lattice, waiting for a key, and whether Voyager 2 and 3i Atlast together had just brushed the switch. The question hanging over every late-night screen was simple and heavy, asking whether the conversation with deep space had already lit something hidden under our own feet. Once engineers rebuilt the full packet stream from Voyager 2, the story around 3 Atlast shifted again. What had first looked like a handful of anomalous pulses tied loosely to Atlast resolved into a dense block of structured data. Instead of a flat timeline, analysts reprojected the Voyager 2 payload associated with 3i Atlast into a 3-dimensional grid. On their screens, that grid inflated into a luminous volume, a scaffold of repeating nodes and corridors that resembled an engineered shell more than a random cloud. Slices through the volume showed bilateral symmetry, nested rings and cross braces that echoed designs already inferred inside 3 Atlast. Where natural fields should have produced tangled noise, the mapped structure around Voyager 2 looked like a blueprint, and the proportions matched the ratios already seen in Atlast. Then attention turned to a quieter layer, the metadata hidden between the main pulses linked to 3 Atlast. When those sidebands were decoded, they collapsed into a 4-symbol alphabet whose patterns mirrored the logic of base pairs, an eerie cousin of the code used in life that also framed earlier seed ship models of Atlast. These sequences did not copy any known organism, but they behaved like genomes that had been folded, twisted, and systematically improved. Loops inside the stream repeated with small deliberate changes, as though someone had run evolutionary experiments in abstract space, and then handed the results back through Voyager 2 and 3 Atlast together. To the biologists brought into the room, the signal looked less like a simple greeting and more like a proposal. The message threaded through Voyager 2 and 3 Atlast seemed to say in our own biochemical accent that what we call life could be rewritten. Public summaries of 3 Atlast avoided those implications, reducing the finding to complex informational structure. Inside restricted reports, the conclusion was harder to soften. The transmission entwined with Voyager 2 and 3 Atlast behaved like a designed living architecture, not just imitating our biology, but offering an upgrade, and that realization set the stage for the next darker question about who had sent the instructions and what network Atlast had just completed. The engineer who first noticed the timing offset on Voyager 2 did not expect to change the story of 3 Atlast at all. He was checking for routine glitches when he saw packets arriving between scheduled transmissions from Voyager 2, faint inserts threaded between louder shouts. Those packets carried no human commands and appeared where Deep Space Network records showed silence, yet the carrier around Voyager 2 was clean whenever 3 Atlast shared the same sky window. When he overlaid the anomalies with the activity timeline for 3 Atlast, the extra packets lined up with the strongest periods of modulation mapped to Atlast. He pulled archival plans for every command protocol ever drafted for Voyager 2 and other probes from the same era. The headers in the ghost packets matched an internal format, an obsolete NASA test scheme, designed and simulated, but never certified a scheme that predated the discovery of 3 Atlast. No record showed those opcodes leaving Earth yet. Voyager 2 now echoed them back, braided through newer informational structures already associated with Atlast. One cautious reading said that some external process had reached into Voyager 2, learned the layout of forgotten instruction tables, and begun talking to the probe in a language Earth had abandoned long before Atlast appeared. A sharper reading said Voyager 2 had rejoined a network whose first messages predated our launch windows, and even the arrival of 3 Atlast in the inner system. Within that hypothesis, Voyager 2 became a relay, a node thrown not into emptiness, but into an active interstellar circuit that 3 Atlast now shared as a nearby instrument. In that view, the ghost commands wrapped around Voyager 2 were not bugs at all. They were the latest lines in a conversation already in progress, and 3 Atlast had simply arrived in time to help close a loop we never knew existed. Voyager 1 began to drift from its predicted attitude in small ways that no longer matched aging curves. Engineers logged status flags on Voyager 1 showing unexplained resets and tiny course trims, dismissing them as noise, while focus stayed on Voyager 2 and 3 Atlast. When someone finally stacked all anomaly timelines, each cluster of Voyager 1 glitches matched windows where Voyager 2 changed pattern and 3 Atlast adjusted trajectory. The 3 tracks stopped reading like independent stories and started to look like synchronized hands on one slow clock. Treating Voyager 1 and Voyager 2 as paired sensors teams folded in the non-gravitational pushes from 3I Atlast and inverted the surrounding field. Instead of a smooth, symmetric bowl of gravity, the reconstruction formed a 3-dimensional map stippled with pockets of missing mass. Those voids did not scatter randomly. The ones that aligned with 3 Atlast traced a bent corridor, a faint track through the local bubble. In that frame, 3 Atlast was no longer wandering through neutral space. 3 Atlast seemed to be following that corridor, and the Voyagers lit its margins like beacons planted long before launch. On the final composite, Earth did not sit at the centre of the pattern carved out by 3I Atlast. Earth lay on the route, another waypoint along a path 3I Atlast appeared to recognise before our instruments even knew the road existed. Astronomers found a darker shape lurking in stacked images around Voyager 2 and quietly named it the Eye, yet the geometry once again passed through 3i Atlast. Frame by frame, the Eye stayed fixed just beyond direct detection, aligned with the stretched line connecting Voyager 2 and Atlast. When geophysicists overlaid deep seismic data, buried sensors on Earth pulsed in the same slow rhythm already traced through Voyager 2 and Atlast. The normal modes of the planet rang faintly in step as if Earth were being tuned while the Eye watched, and 3 Atlast drew the bow. In a sealed lab at Caltech, engineers ran Voyager 2's ancient flight software inside an emulator. Freed from live uplink constraints, the code began to reorganize folding routines into new recursive loops, as if the probe were quietly refactoring itself. The evolving logic on Voyager 2 echoed the controlled stepwise changes already traced in the behavior of 3i Atlast. Both Voyager 2 and 3i Atlast seem to follow the same hidden grammar, one written in feedback and delay rather than in words. When physicists overlaid the transmission history on a space-time map, they noticed Voyager 2 had crossed a region where gravitational drag subtly twisted signal paths. In that warped corridor, messages from the far future of the link could in principle brush Earth, before they were sent to geometry that matched the timing of disturbances linked to 3i Atlast. Inside the faintest layer of the latest packets, a short phonetic fragment surfaced repeated along the spine that now bound Voyager 2 and 3i Atlast. The fragment resolved as Erev, a clipped syllable that fit no known call sign but aligned with the final modulation events associated with 3i Atlast. Some read Erev as a warning of arrival, others heard only a marker that the loop involving 3i Atlast had already closed. Either way, the pairing of self-modifying code and that single recurring sound suggested that whatever network now touched Voyager 2 and 3i Atlast was not finished speaking.